sunny Friday afternoon from Istanbul, but we might be all over the place. I don't know where you're connecting from. This is the third online academic seminar of the 2021-22 spring semester. And we're hosting today Dr. Hasan Özgür Kapıcı, and he's going to deliver his talk titled Using Hands-on and Virtual Laboratories Alone or Together, which works better for acquiring knowledge and skills. So the floor is yours, and we'll have about 35 minutes for the talk, and then we'll have a Q&A session.
Thank you very much, Dr. Oder, for this nice introduction. Let me share my screen. I think. Now is it okay? Today, I would like to share some parts of my PhD study, and the title of my presentation is Using Hands-on and Virtual Labs Alone or Together, which works better for acquiring knowledge and skills. This is the roadmap that I would like to follow today. Firstly, I will very briefly talk about the importance of labs in science education, and then I will list.
I'm sorry, Hasan, but we're still on your first slide. I don't know if you moved on to the second one. If so, we're still seeing your title. Now it's on the second page.
Is it okay now?
Now it is, yeah.
This is the roadmap that I would like to follow today. Firstly, I will state the importance of labs in science education very briefly, and then I will talk about the advantages and disadvantages of hands-on and virtual labs. And I will state the goal of the study and the research question that I would like to investigate in this study. Then I will share the methodology that I use to find an answer for my research question. And then in the end, I will share the results and discuss the findings based on the results of the study. There are several roles of science labs in science education, and some of them are listed here. And the basic and fundamental roles of labs in science education is increasing students' conceptual knowledge, domain knowledge, and it's also helpful students to improve their psychomotor skills, and also enable students to act as real scientists in the hands-on lab environment, because students design and implement their own experiments and collecting and analyzing their own data. That is the way how scientists work in their labs. Also, in hands-on labs, students get familiar with how to do accurate measurements by using the tools in the lab environments. On the other side, students spend much more time for procedural things in hands-on lab environments than the scientific discussion, which is a handicap for both teachers and students. And also, it is almost impossible to ignore the real-life variables such as friction force or air pressure in the hands-on lab environment, and which can cause wrong measurements and may result in misunderstanding. And not only students, but also teachers may have difficulties in hands-on lab environments due to lack of devices or equipment.
Hasan Özgür, I'm sorry to interrupt again, but we're on the roadmap page still.
Hasan Özgür, would you start the presentation? Like, we are not seeing your slides in the presentation mode right now.
Yeah.
I will share again, please.
Yeah.
Yeah, let's make sure it's moving from one page to the other, and then leave the floor to you again. So we're on the second slide.
Slides?
No, we're still on the second slide.
Oh my God.
Do you have two screens? Is that the reason?
Now I totally closed all my Presentation, turn on again. Now on the first page of the presentation.
Yep.
Can you try navigating through slides?
Okay. The second page now.
No.
You should start the presentation mode at the bottom, or you can just simply press F5 on your keyboard.
Okay.
Now we're on the fourth slide.
Yes, I'm also on the fourth.
And we can see your cursor. So maybe if you switch to the fifth one. Yes,
Yeah.
now at least, yeah, we can see the slides now.
Now sixth page.
I'm on the fifth page at the moment. Pros and cons. Now on the sixth page, yeah. Disadvantages.
Continue like this. If there's a problem, then you can again warn me.
I'll give you a shout.
Sorry for this problem, but I don't understand very well why this happened. In the hands-on lab environments, students mostly spend more time to design their experiments rather than scientific discussion, which is a handicap for both teachers and students. And also, it is almost impossible to ignore the real-life variables such as friction force or air pressure in the hands-on lab environments, which can cause wrong measurements and may result in misunderstanding. Also, not only teachers, but also students may have difficulties due to lack of devices or equipment in the hands-on lab environment. In order to handle with these restrictions, virtual labs may provide several solutions. For example, they can offer safer environment, for instance, accidents based on chemicals, or students are able to do much more experiments in a limited time without decreasing the equipment. And also learners don't have to wait too much to gather data because the system works dynamically and provides rapid data display. Also, it's portable and students can reach virtual learning environments wherever they have an internet connection. It's also possible to convert the intangible concepts such as electricity or particulate nature of matter into tangible forms in the virtual lab environments. In addition, teachers can simplify the topic by eliminating the detailed knowledge, and in this way, students can easily focus on the key concepts of the topic through the virtual lab environments. Last but not least, it's also possible to insert online scaffolding tools into the virtual lab environment, and which have crucial roles in inquiry-based learning approach. Although all these affordances are held by virtual lab environments, they also have some weaknesses. For example, they are not good environments to develop students' teamwork abilities because students mostly work on computers, on tablets individually. And also, it is almost impossible to find an answer for every research question because the system has its own restrictions and involves only specific variables. So students have to design their experiments based on the properties of the virtual environment systems. In addition, in the virtual lab environment, the system represents the simplified version of the real entities. And so students may have difficulty to understand the real structure of the concepts or entities, and which can also have potential to cause misunderstanding for students. And recently, researchers have begun to investigate the effects of using hands-on and virtual labs in a sequence or in a combination because of the fact that each lab environment has its own affordances. And based on these facts, this research question was determined as follows. For this study, the 7th grade middle school students will learn about the domain of electricity in a pure hands-on lab, hands-on alone. I mean that in a pure virtual lab or in an alternative combination of these two laboratory environments has an impact on students' knowledge acquisition and improving their inquiry skills. As a methodology, The study is based on a quasi-experimental research design, and 143 students, 7th grade students from 4 different 7th grade classes were participated to the study, and 1 science teacher instructed for all these 4 classes. And these 4 classes were coded as HHH, VVV, HVH, and VHV. And here H represents hands-on and V represents virtual. And the sequences of the letters show the sequences in which the laboratories were offered. I will provide some more information about this a few minutes later. And the table here shows the number of students per condition. And for each condition, there were more than 30 students. As instruments, we used 3 different data gathering tools. The first one was multiple choice conceptual test, and the second one was open-ended conceptual knowledge test, and the last one was the inquiry skills tests. The multiple choice conceptual knowledge test was developed by Sancar Tokgöz for her PhD dissertation and involves 28 questions. 22 of the questions are multiple choice questions, 3 of them are true-false questions, and the last 3 questions are the matching questions. And for the current study, Chrome alpha was found as 0.80 according to the post-test implementation of the multiple choice tests. Open-ended conceptual knowledge test was developed for this study by the researchers in order to understand how students comprehend the concepts in the topic of electricity by enabling them to make drawings by themselves. And in order to ensure the content validity, we firstly considered the objectives from the unit of electricity. And then we developed several questions based on the objectives, and a researcher who has undergraduate and graduate degree from the physics education department and 1 science teacher, middle school science teacher, examined and revised the tests. And the revised version of the test was piloted with 24 7th grade students. And based on the responses of the students, we revised several terms that have potential to cause misunderstanding by the question for the students. And in the final version of the test, it involves 6 open-ended questions, which require drawing circuits, analyzing graph, or writing explanations. In order to assess the data gathered from the open-ended conceptual knowledge tests, we use 3 different categories. The first category is the fully correct category. Here, students receive 2 points for their correct answers. For example, there are 2 figures here which show students' answers. For the first figure, we see that the students drive the circuit correctly and emphasize that which bulbs are serially connected and which bulbs are parallelly connected. That's why he or she received 2 points. And here again, the students drive the circuit correctly and added the voltmeter and ammeter correctly to the circuit. That's why the student received 2 points for his answer, or her answer. The second category was the partial understanding category. Here, students receive 1 point for their responses. For example, here, although the students drew the circuit correctly, he or she didn't mention here which bulbs are parallel or which bulbs are serially connected to each other. So he received partial credit. And the third category was misunderstanding or no answer category. Here, students didn't receive any credit. In order to determine the integrated reliability, 20% of the data was analyzed by 2 different coders, and the agreement based on the 2 raters coding was 81.3%, and the differences between these 2 coders were discussed and reached a consensus at the end. And then after that, the remaining part of the test was analyzed by 1 of the researchers. And the last data gathering tools used in this study was inquiry skills test, which was developed by Aydoğdu for his PhD dissertation. And it also includes 28 questions and aims to measure students' basic and higher order inquiry skills through the multiple choice questions related to the topic of electricity. And for the current study, we found the Chrome alpha coefficient as 96 for the post-test score of inquiry skills tests. In terms of the research design and implementation, firstly, we determined the topic of electricity for this study because this topic is appropriate to do experiments in both hands-on and virtual lab environments. And after that, we divided the unit into 3 sections with respect to the curriculum. The first section was the serial and parallel circuits. The second section was adding ammeter and voltmeter to the circuits. And the third section was Ohm's law. And for each section of the units, we developed 3 different lesson plans with the science teacher, and also some basic technical issues and how to use virtual lab environments were shown to the science teacher. And in the end, we also developed a lab worksheet for the students in the hands-on lab environment, which is very similar to the virtual lab environment. And here, after that, the 4 classes were randomly assigned one of the conditions in the study. And for example, here the HHH condition means that the students in this condition did all their experiments in the hands-on lab environment for the 3 sections of the units. In the VVV condition, all the students in this group used virtual labs throughout the unit. And the other 2 combination groups, for example, the condition VHV, they did the first section of the units in the virtual lab, and they used hands-on lab for the second section of the unit. And then in the end, they used virtual lab again for the Ohm's law topic of the unit. And the last condition followed the reverse way of this condition. They used first the hands-on lab, then continued with virtual lab, and at the end, they used hands-on lab again. After that, the tests were taken as pre-tests at the beginning of the study after assigning the classrooms in the condition. Then we prepared exercises with the virtual lab for the students in the VVV, VHV, and HVH conditions, because students were not familiar with the virtual learning environment. Before the real implementation process, we wanted students to get familiar with the virtual learning environment. That's why we separated 2 class hours to get familiar with the virtual lab environment with another topic. After that, because of the limited computer facility of the school, the students worked in groups, and all of the students from all of the classes were divided into group of 3 by using the alphabetic ordering of the classroom sheet. And then at the end of the study, the same tests were taken as post-tests. All of the study lasted for 6 weeks, and for all conditions, we use guided inquiry learning approach. As a guidance for the hands-on lab environment, the science teacher acted as a main source of guidance. She acted as a main guide for the students in the hands-on lab environment. Also, at the beginning of the study, as I mentioned before, we prepared a lab worksheet, and this lab worksheet was also provided another scaffold for the students in the hands-on lab environment. For the virtual lab environment, we used 3 different online scaffolding tools in the 3 different phases of inquiry cycle. These phases were hypothesis generation process, the experimentation phase, and for the conclusion stage phase. For the hypothesis generation process, if students were assigned to be in the virtual lab, they were provided with the online hypothesis scratchpad tool. And if they are in the hands-on lab, it is written equivalent form provided for the students. Here we can see the online hypothesis scratchpad. Several variables and concepts were provided to the students, and students should just drag and drop their concepts here to create their own hypothesis. Also, they were free to create their own hypothesis by using their own words. In the hands-on lab environment, the equivalent written form of the online hypothesis scratchpad was provided for the students. The same concepts and variables provided for the students. They also they were also free to create their own hypothesis. They just write these concepts or variables to create their own hypothesis in the hands-on lab environment. For the experimentation phase, a brief demonstration video which shows how to create an electric circuit on the virtual lab environment was shown to the students in the virtual lab environment. And for the students in the hands-on lab environment, the science teacher in front of the classroom showed how to how to create an electric circuit, basic electric circuit. And of course, for both hypothesis generation process and experimentation process, the teacher actively guide the students how to create their hypothesis or how to design their experiment. For the conclusion stage, we provided online conclusion tool for the students in the virtual lab, and it is almost equivalent form in the written on the lab worksheets for the students in the hands-on lab environment. Here we can see the online conclusion tool. Here students were able to see their hypothesis and their observation notes taken during experimentation, and students used these two different sources to create their conclusion here. And for the students in the hands-on lab environment, students had to write their hypothesis here, and they had to also consider their observation notes while doing experimentation they took. But by considering these two different sources, they had to write their conclusion here. For the data analysis section, the same approach was used for the multiple choice and inquiry skills tests. Firstly, we used one-way ANOVA to compare the pretest scores of the 4 classes, and then paired samples t-tests were implemented to evaluate how each condition's conceptual knowledge or inquiry skills change from beginning to the end of the study. And in the end, we used an ANCOVA to compare the conditions post-test scores by taking the relevant pretest scores as covariant. Yet we didn't reach a normal distribution for the open-ended conceptual knowledge tests. That's why we used the non-parametric tests. And firstly, we used Kruskal-Wallis test to compare the students' pretest scores from 4 conditions. And then we used Wilcoxon test to compare the pretest and post-test scores of each condition and to realize how their conceptual knowledge changed throughout the study. And in the end, again, we used an ANCOVA to compare the post-test scores of the conditions by taking the relevant pretest scores as covariant to compare the post-test scores of the 4 conditions. And this table shows the descriptive results for the multiple choice conceptual knowledge tests, and we can see that the larger mean differences were reached by the combination conditions more than hands-on alone or virtual alone conditions. And the ANOVA results showed that all conditions were equivalent to each other at the beginning of the study, and all paired sample t-tests showed that each condition increased their conceptual knowledge throughout the study. And ANCOVA results indicated that there was a significant difference between conditions post-test scores. And in order to understand which groups post-test scores are reliably different from each other, we implemented post-hoc analysis, and post-hoc comparisons showed that the conditions who used virtual and hands-on lab in combination reached significantly higher score than the virtual alone conditions. For the open-ended conceptual knowledge test, firstly, we examined the correlation between multiple choice and open-ended conceptual knowledge test, and we reached this low correlation between these two tests. And this shows that these two tests measured something different from each other. And again, the descriptive data showed that the combination groups reach larger mean differences than other two conditions. And Kruskal-Wallis test results showed that there was no significant difference among two conditions at the beginning of the study. And in the following step, Wilcoxon test showed each group enriched their conceptual knowledge significantly throughout the study. And also the ANCOVA results indicated that there was a significant difference between post-test scores of conditions. And again, we implemented post-hoc analysis to see which groups post-test scores are significantly different from each other. And we reached that the condition VHV class reached significantly higher score than the virtual alone condition. And this finding also showed that using virtual labs alone doesn't give successful outcomes as much as using a combination of hands-on and virtual lab environments. For the inquiry skills test, firstly, again, I started with the descriptive data, and we can also see that the mean differences were larger for the combination groups. And the ANOVA results again showed no significant difference at the beginning of the study in terms of students' inquiry skills. And paired samples t-test showed that although 3 conditions improved their inquiry skills significantly, the HHH condition didn't achieve this. Although they increased their inquiry skills throughout the study, it was not statistically significant. In addition, the ANCOVA results didn't show any significant difference between the groups' post-test scores, and that's why we thought that using either hands-on or virtual lab environments have equally effective to develop students' inquiry skills from all conditions. For the discussion, the results of the conceptual knowledge test indicate that using hands-on and virtual labs in a combination should be preferred rather than using virtual labs alone. This conclusion is also parallel with some other studies in the literature, but also contradict with some other studies from the literature. These different results may be explained students involved in these studies. For example, our study has similar conclusion with the Zakaria and Michel studies because they also involved middle school students in their study, and they also reached that the combination groups reached significantly higher scores than using virtual lab alone. And so our study is parallel with the results of the Zakaria and Michel studies. On the other side, Zakaria and Olympiou in the other study, they did their study with undergraduate students, and they didn't reach any significant difference among the condition, whether they used hands-on and virtual in a combination or alone. That's why the students involved in these studies can be a reason for these different results. Another reason can be the experience of students have with the virtual lab environments, because it's a fact that learning environments have crucial roles on students' learning. And in our study, it was students' first experience with the virtual lab environments, and this can be a reason why the students in the VVV condition reach lower scores than the other 3 conditions. In terms of the combination groups, we didn't reach any significant difference between the 2 combination groups. And also there are some studies in the literature which also didn't find any significant difference between the combination groups. But recently, researchers have begun to found that if students start with virtual lab and then continue with the hands-on lab, may have potential to reach more deeper understanding. They advocate that basic concepts of the topic can be taught by using virtual lab, and in order to enrich students' detailed knowledge, complex experiments in the hands-on lab can be used. That's why they prefer to use virtual lab first and then continue with the hands-on lab environment. For the open-ended conceptual knowledge test, mostly it has generally pointed in the same direction. In terms of inquiry skills, we didn't find any significant difference in terms of lab environments on middle school students' inquiry skills. Also, there are several studies who reached that virtual and hands-on labs are equally effective for improving student inquiry skills. But the crucial point here is that using guided inquiry approach, because if we use guided inquiry approach, it's not so much important to use whether hands-on or virtual lab. The more important thing is that using guidance throughout the inquiry-based learning environment. But however, we reached that although VVV, VHV, and HVH conditions improved their inquiry skills significantly, the HHH condition didn't achieve this. We thought that this can be due to the effectiveness of paper-based worksheet used for the hands-on lab environments, maybe students found the online scaffolding tools more easier to use in the inquiry-based learning environment. So this is another topic to investigate by the researchers for further studies. As a conclusion, we can conclude that using hands-on and virtual labs together gives significantly better outcomes for student achievement than using virtual lab alone. And also we can state that virtual and hands-on lab environments have equal effect on increasing student conceptual knowledge and inquiry skills, because we didn't reach any significant difference between the VVV and HHH conditions. And in terms of implications for science teachers, firstly, we can suggest science teachers to use virtual labs if they want to use, because they are effective at least as much as hands-on lab. Secondly, of course, we would like to advise science teachers to use hands-on and virtual labs in a sequence or in a combination, which have much more fruitful outcomes for their students. And I would like to thank you all for listening to me. And if you have any questions, I would like to try to explain if I can.
Thank you, Hasan Özgür, for sharing this interesting study with us. So now I think we can open the floor for discussion, for questions. We have approximately 25 minutes if we want to use all that time.
Mm-hmm.
Okay, Gülseren Karagözakar has her hand up. So yes, please, Gülseren.
Thank you so much, Engin. Maybe I can ask something. Like I came in the last minute, but I had a question actually. I just could hear some of your presentation, Hasan Özgür. You said like in the implications, the results of studies suggested that hands-on activities, students doing experiments hands-on versus maybe virtually, seems like there's no significant difference between them. So you are saying, seems like hands-on is better than, or maybe more important than hands-on, activities. So could you elaborate on like the guidance, process that you were referring to as a reason why the virtual labs might be as effective as like hands-on, experiments? So could you explain, like maybe just, elaborate on what we mean by guidance of the teachers or inquiry-based learning? Like what do the teachers do even like during this virtual lab, situations, so that like students seem to be gaining a lot, even if they don't do those experiments, in person?
Mm-hmm. Yes, indeed, the important thing is, as I mentioned, the inquiry-based learning approach followed in whether in hands-on and virtual lab environments, because in inquiry-based learning environments, we want students to act mindfully. Indeed, it is not certain necessary to use their hands it is not necessary to act physically in the labs to reach the required knowledge, because they should use their minds and they should act consciously, whether they use hands-on or a virtual lab. That's why, in addition, there are also some studies in the literature about this. For example, Zakaria in 2015 published a paper. He examined whether physically sensory input is required to gain knowledge. something like that. But he concluded that it is indeed not an obligatory process needed to gain knowledge in labs. The most important thing is that students should know what they do in the experiments. They should decide the variables. They should know which is independent variable, which are dependent variable, or which are control variables. And it's not, of course, hands-on labs have potentials to improve psychomotor skills if they are younger learners. But if they know what are they searching or what they are trying to do in the lab environment, this is more important than using either hands-on or virtual lab environment. Also, when we consider the advantages of virtual labs, such as time and cost efficiency, portability, and providing safer environment for students, and also teachers can provide basic concepts about the topic by eliminating the detailed knowledge about the topic, and students can easily focus on the key concepts on the virtual lab environment. And when we think these advantages of virtual lab environment, it is possible to use virtual labs in the schools as much as possible. Of course, it is. I don't want to hear here. I don't want to say that virtual labs are super, or we should every time use them. I don't want to say something like that. But I want to say these two lab environments have complementary roles, and we should use the strong sides of these two lab environments. Thank you very much.
Thank you.
Any other contributions? Olga, go ahead, please.
Hasan, thank you very much for a very nice presentation. And I'm glad to see in the audience more people away from Boğaziçi, from Jyväskylä, from University of Twente. This is great. Thank you for joining. I have a few questions to ask you. And these questions come mainly from my experience with teaching in the lab, in a traditional lab, I would say, with pre-service teachers. Okay, let me ask only two questions. The first question is, what do you mean by your term inquiry skills? Of course, we know these inquiry skills approach, the literature and all these things. But I was wondering to what extent what you have done, the topics that you worked in your lab are related to this inquiry approach, how much freedom you give to your students. And then I have some doubts, but you have used written tests in order to assess your students' conceptual knowledge. And if I'm right, have you used written tests to assess your students' inquiry skills? And these questions are related to each other. So what do you mean? How do you define your inquiry skills? What inquiry skills you want to teach and you want your students to have developed through these lab activities, please? And how is this related to the tests? Are there any more tests that you have used in your lab? Thank you very much.
Thank you, Olga. And I mean that by stating inquiry skill, I mean that defining students their own research questions or hypotheses, and to design their own experiments to find an answer for their research questions, and gathering and analyzing their own data, and reaching a conclusion and making an inferences. But of course, in our case, we studied with the middle school students who have almost no experience with the inquiry-based learning environments. And if you look at the scores of inquiry skills test gathered from the students, we reached very low scores even after the even from the post-test score of inquiry skills test, they were very low and limited for the students in our study. That's why they didn't have so much freedom in the inquiry-based learning here. That's why I emphasize that we used guided inquiry in this study, and the teacher mostly helped the students in every phase of inquiry cycle. For example, while generating their hypothesis, the teacher checked all students, all groups, all groups' hypotheses individually and gave feedback to them. This is a wrong way, this is a false true way, and something like that. The teacher always directed the students to create their own hypotheses while designing their experiments, and always helped the students throughout the learning process. And I didn't show the slides about the inquiry skills test questions. Indeed, I had data, for example, how many questions aims to observation skill of students, how many questions aims to designing experiment skill of students. All these different basic and higher order skills involved in the multiple choice questions, and all the questions were related to the topic of electricity, because we did the study on the unit of electricity, and we wanted students to consider their own experience while answering the questions on the multiple choice tests. But it is not an easy task, especially if students are naive or not familiar with the inquiry-based learning approach. So, as I mentioned, we need more studies to investigate the effects of guidance in inquiry-based learning environments, whether it should be by the teacher or computer systems or paper-based scaffold, which works better. We should do more experiments, and of course the level of freedom can be changed from based on the student's experience. For example, at the beginning of the term, maybe the teacher can use more guided inquiry, and when step by step, when students get familiar with the learning environment, and the teacher can take out some more scaffolding, and the freedom can be get more larger throughout the semester. And I think that throughout the end of the semester, maybe open-ended guided learning can be, open-ended inquiry-based learning can be used even in a classroom. But this needs times and experience of students. Okay. I don't know whether I answered your question exactly. But...
Okay.
Any other follow-up questions, comments? I might jump in and throw a short, quick question, Hasan, Özgür. Where do you think the immersive environments might stand within this debate? I don't know if you've had any chance to go into that strand of research, or whether you're planning to do. As far as I know, they're not many. There are some lab environments, some really good lab environments on screen, but I don't know if this is under your radar at the moment.
Indeed, for now, I'm not very familiar with the virtual reality environment, but recently we wrote a research proposal which includes virtual reality, virtual lab, and hands-on lab environment. And as I know, virtual reality is a combination of hands-on and virtual lab environments, because in the virtual reality, students act physically but manipulate the variables virtually. So it seems that it has the strong sides of hands-on and virtual labs together in itself. So as I mentioned, I am not very familiar with, but when I think theoretically, or when I just think about virtual reality, it may have some more potential than using just alone hands-on or using just virtual lab environments, because as I mentioned, it's a combination forms of hands-on and virtual, because students when they use the eyeglasses to enter the virtual lab environment, they use their hands as like in the hands-on lab environment, but they manipulate the variables virtually, so they gather accurate measurements, but they also their psychomotor skills. And I think that it seems better way to help learners gain more conceptual knowledge and skills, but I'm not sure, of course. We need more studies about this to compare.
Thank you.
You're welcome.
Yeah.
Yes.
Son Young is making a comment about yeah, because it's I think it's an interesting debate whether virtual reality can itself can be considered as a combination of the two, but augmented reality as stronger links with reality, whereas in one you're immersed totally in the virtual environment. So these might be interesting ways forward for we need evidence about the empirical evidence about potential influences of such environments on learning and inquiry. Any other comments? Terry Mantila, please go ahead.
Yes. Hi, Hasan. I was wondering about how do you see the possibilities of these open-ended investigations in these virtual labs, and how would you see?
Could you please repeat your question, because the voice?
Okay, let's see. Can you hear me now?
Yes.
Yes. So how do you see the possibilities of open-ended investigations to be implemented in virtual labs? And then the other question is, how would you see how one would develop the virtual labs in future, so it would be better suited for the needs of inquiry learning?
Thank you very much for your questions. And of course, one of the biggest disadvantages of virtual lab environments, it has restrictions to do every experiment in the virtual lab environment, because the virtual lab environments involves limited variables in their systems. So if you want to use full open-ended inquiry for the virtual lab environment, then we should firstly choose the virtual, before the study, we should determine the virtual lab that whether it can answer most of the questions that can be generated by the students. That's why we should find a better learning environments for this situation. I think we need more computer programmers who study about instructional technology to develop better virtual learning environments, because we want, if we want to do every experiment as we do in the hands-on lab environments, we should develop the virtual lab environments as much as possible. And so I think we need funding for this to develop virtual labs, various virtual labs, or virtual labs that can answer most of the questions can be generated by middle school students or high school students. For now, it is not very much possible, of course, to use virtual labs for, I think, for the open-ended inquiry very well. yeah, we always need to do some restrictions. We need to obey some restrictions generated by the systems. Okay, thank you very much, Terry.
What is the next step? Do you have concrete ideas?
For me, next step for the further studies.
Yes, as a follow-up, some concrete plans for following this up.
I think we should investigate how virtual and hands-on labs causes cognitive loads for students. Maybe we can here we can design the learning environments better based on the results of these studies, if which causes more cognitive loads for students, and we can try to eliminate the reasons that causes cognitive loads for students. And by eliminating these, maybe we can design better learning environments for students. And also, I also would like to wonder or investigate the learners' eye tracking, whether in hands-on and virtual, and also virtual reality labs, to see where they focus on while learning in these learning environments, whether how high period knowledge students follow how high learner students follow the paths in these environments, how low successful students focus on the environments in these laboratory environments. And I would like to compare the outcomes of such studies to make students who have low period knowledge to follow the ones who have high period knowledge. Maybe we can provide more support for the low successful students. I'm not sure if I am able to explain it clearly, but I have these ideas. One is the cognitive load caused by these environments, and the second one is following students, eye tracking, how they learn, different level of success students, how they learn in these environments, and what can we do to support the low period knowledge students in these environments.
Probably it makes sense that they are a bit messy at the moment, some of your thoughts, so they'll get more organized as you dig in and design those steps. Okay, maybe one final question or contribution before we finish for today. Okay, we have one more question. Salome Werner, please go ahead.
Yeah. So I have a kind of general question, Hasan. What fascinates you about virtual lab? What made you do research on it? I am really curious about that.
Why did I decided to do research on virtual? Because the technology has been developing rapidly, and it's a fact that educational or learning environments has been affected by the technology. And I thought that the education can be done virtually also, but not only virtually, because in the pandemic term we saw that if we use the distance learning always, it's not gives better scores as much as face-to-face learning. But I thought that we should use educational technology effectively to enrich students' knowledge, skills, attitudes towards science, because if the students be able to use technology as much as possible, and they will be able to understand how these systems works. Maybe the virtual lab environments attract students' attention behind the content provided to them. Maybe they can think about the coding systems or something like that. I mean that they can show more. They can be more motivated when they learn virtually. That's why I would like to investigate the positive sides of instructional technology on education. And when I think about in terms of science education, virtual labs was recently news topic for especially for researchers in Turkey. So I decided to investigate how virtual labs works when we compare to hands-on labs, and that's why I decided to study more about simulations, virtual labs, and hands-on labs comparisons. Thank you.
Okay, I think we had a nice opportunity to hear some follow-up questions and your extended ideas, comments regarding these. So I'm just looking around for one last opportunity, guys, but it looks like, yeah, it might be a good time to conclude this session. Thank you very much for your presentation, Hasan, Özgür, and thank you all for attending and contributing. So hope to see you in the further academic talks of our faculty.
Thank you very much for your attendance and listening to me.
Thank you very much.